Well, good morning, good afternoon, good evening, depending on where you are in the world watching this. This is going to be a new series of multi-part videos that I'm going to put together that envelop the final project that my students have to compile at the end of their network support services course. They build a multi-subnet network with various systems, routing, Windows deployment services, DHCP, distributed file system, a lot of different systems. So I'm going to begin in part one, and as I said, this will be multi-parts. Part one is going to be creating my virtual infrastructure. And I may, depending on how fast we get this fired up, I may incorporate my routing as that same video, or I may separate it into part two. But let's begin. So I don't like to have to point and click and type and do all sorts of things, so I like to use PowerShell. As you can see on your screen, I've crafted a PowerShell script using PowerShell ISE, and what I did first was I created a parent disk. I'm going to use differencing disks. This allows me to turn up a virtual machine in minutes, not moments, but minutes, with a parent-child relationship. So I took a copy of Windows Server 2016 Data Center Eval, created a virtual hard disk, created a virtual machine, installed the copy of Server Data Center, configured it, ran Windows Update on it, set my time zone, set a couple of specific settings, and then I sysprepped it. When we sysprep it, it strips the SID from it. We set it to do the LOBE, the out-of-box experience, to generalize, and to shut down. This enables me to make as many copies as I need of that virtual hard disk, or I can use it in my parent-child relationship. Then, to ensure that I don't accidentally make changes to that parent, I navigate in my file system to that VHD that, as you can see on your screen, I labeled Windows Server 2016 parent.vhdx. I right-click on that and I flag it as read-only. This ensures that I'm never going to change it. Remember, this is just a reference. In my script, I create 8 differencing disks that all point to that parent disk. Then I create my new virtual machines with the same corresponding name. Naming convention is critical. I don't care whether you're doing virtual machines, whether you're doing physical computers, whether you're doing networking. How we name things, how we assign IP addresses is critical. We need to use uniform naming. So, since this is a reference to our final project, all my virtual machines, all my disks, all are prefixed with the word final. I specify a gigabit for startup memory. They're going to be generation 2 virtual machines, and I point to the hard disk. I then create 3 private switches: final subnet 1, final subnet 2, and also a final WAN link. Because I'm going to create 2 separate servers, I'm going to have a link between those. If I didn't want to be that complex, I could create a single router with multiple interfaces with an external facing interface, and then 2 virtual switches connected, and just build it off of that. But you know what? I want to represent a real world environment. We're going to create a WAN link between our routers just as if it was between 2 locations. Then, since I also want to be able to control the memory that I'm using, I set my VM memory. I specify that dynamic memory is enabled. Here again, that's startup memory of a gig of RAM. Use a minimum of 512, but a maximum of 4 gigabits. This way I know that no particular server is going to run away with too much RAM. Then, since when we create a virtual machine, it automatically attaches a network adapter to it, I say, hey, get that network adapter, and by default it's named network adapter, and connect my final subnet 1 to final router 1. Connect the final subnet 2 to final router 2. Now I need some additional interfaces. I need to add my WAN link. I need to add the external adapter so I can get to the internet. I need to add to my second router that same WAN link. Now I can connect the two routers. Then I add the network adapters. I go ahead and I say, hey, when I created these VMs, here's that network adapter. Final DC1, connect to subnet 1. Final DHCP, connect to subnet 1. Final WDS, connect to subnet 1. My distributed file system 1, connect to final subnet 1, and then my domain controller 2, subnet 2, and my DFS subnet 2. So you can see we're not only having two locations, we're having two domain controllers. That way we can see replication occurring as user accounts are created, DNS changes occur, just the same as we would in a real environment. And then finally, since this is just a test environment, I go ahead and I tell it to set automatic checkpoints off. Now, I could do loops, I could do all these other things, but I just wanted to represent this in its basic form without a lot of complex scripting so you can see each individual step. Let's go ahead and fire it up. Let's see how long it takes to create this structure. Virtual hard disks are being made. Here's the last of the disks. Virtual machines are being created. DC1, DC2, DHCP, WDS, DFS1, DFS2. Virtual machines are made, assigning the network adapters or creating the switches first, then assigning them, and we're done. If I switch over to my Hyper-V, I can see there are my 8 virtual machines. I can go to Switch Manager. There are my 3 specific virtual switches, 1 for each subnet, 1 to link between routers. If I examine the settings for any one of these, I can see my memory. I can see my memory is set to exactly what I want it to be. I can see the hard drive attached. I can see the network adapter set the way I want it. I can see that automatic checkpoints were turned off. Everything's done. I'm ready to build. Now, here's the cool part of that differencing disk. I'm going to begin with router 1. I'm going to connect to it. So yeah, I'm going to roll right into my router setups because, what am I, 10 minutes into this video? Maybe less? Let's turn router 1 on. Should only take a few moments, and we're going to already, remember, the parent disk is already set up. All we're doing is creating the difference, thus differencing disk, the difference that makes this server unique. It's already rolling through, and it's going to, there, getting ready. Typically, how many times do our servers or our systems restart when they're configuring? Twice. So we can expect to see this restart twice. Now, when you're crafting your final project, we need to assign a domain name, right? Well, if this is a production system, obviously it's going to be a domain name that reflects your company or the department or the role that it's going to be performing. I'm simply going to call this project.local. That way I can ensure that I'm not going to conflict with any domain name that may already exist. Hey there, and they're telling us, look, it's already set for United States, English, US, and remember, I'm not using an auto unattend here, so I've got a couple questions to answer. I'm going to click Next. I'm going to accept the user license agreement. I'm going to set the same password that we've been using all along in our lab environments. That's for my local administrator account. There we are. Hey, router 1's up and running. You know what? We're going to configure this, but before I get into configuring router 1, I'm going to tell router 2 to start up. And I'm not even going to open it. I'll let it go through its setup, and when I'm ready, I'll connect to it. Let's go ahead. We're going to log into our router 1. How quick was that? How cool is that? What was that, like 1 minute to fire up a server? Your boss comes to you and says, hey, I need you to build this custom environment. We need to test this out. Can you have this done by the end of the week? You go, well, you got to give me some time. Let me get this up. 20 minutes later, you're up and running, and you're going, yeah, we're good. Okay, so my external facing adapter, it's already gotten a DHCP address. So we're going to go ahead and we're going to accept that. My server manager should come up here in a moment. We're just going to wait for that to come up. While we're waiting for that, I am going to go over here to router 2, and we're going to open that up. Look, it's already here. We're ready to go. I'm going to next, accept. We're going to set that same password. Remember, when we're working in production environments, we do not use common passwords. Never, ever. We disable that administrator account. We create an alternative account first. We're going to be doing that, by the way. Here comes my router 2. Still waiting for my server manager. I've seen this sometimes. Sometimes it takes a little bit. I mean, if we jump back over here to Hyper-V, I can see it's pulling 4 gig of RAM. Now, that's not uncommon. I've seen that many times. I guarantee you, were I to shut this virtual machine down and restart it, it would start behaving nicely. We'll use that term, right? It would not want to use all its RAM. I'm just going to let it sit there. I'm just going to let it find its way in the world, so to speak. We'll see what happens. If it doesn't want to play nice, I'll shut it down. I'll reboot it. There comes Server Manager. You know, after I rename this, in fact, you know what? It's a router. It doesn't need to be renamed. But after I start assigning names to my network adapters, and I've got my static IP addresses set, before I do any roles, I'm going to go ahead and refire this thing up. Let's see if we can't get that memory to come back down. So here we are. We're up and running. Server Manager is loading. We're just about up and ready to configure this. Let's see where our other one's at. Our other one's already up and running. Look, see, it's behaving nicely. It's only using 1.2 gig of RAM. The other one's maxed out at that 4 gig. Had I not set that maximum RAM, it probably would be pulling every bit of memory that this host computer has. This is why we do these settings. Since it's still kind of thinking, well, you know what? It looks like it's done. Let's go ahead. We're going to go local server. Here's some of those settings. Remember when Microsoft configures these ISOs, where are they located? They're on the west coast of the United States. So they're always set for Pacific. Yeah, sorry about that. They're always set for Pacific time. This is one of the things that we set in that parent image. We set it for our time zone. We do things like that. Okay, look here. I've got 3 network adapters on this. One's going to be my external facing. One's going to be connected to subnet 1. One's going to be for my WAN interface. But which one is it? If I go to network connections, well, I can see which one's my external because it got a DHCP assigned address from my school district. I'm going to right click and I'm going to rename this. I'm going to call it external. That was easy. That's going to stay DHCP assigned. My other 2, which one's going to be for my subnet? Which one's going to be for my WAN link? It's important because if I flip them, I'm not going to have connectivity. What do I need to do? I need to take a look at the status. I'm going to go to Ethernet 2 first. We're going to look at status. I'm going to wait. Here we are. I'm going to go to details. Remember, all our Hyper-V network adapters are prefixed with the MAC address 00155D. It's those last 6 hexadecimal characters are important. And you know what? I'm not even concerned about the first 4, just those last 2, 98. What does that tell me? That tells me the MAC address of this adapter. Where else can I find that? In Hyper-V Manager. So I'm going to switch over here to Hyper-V Manager. Down here, I'm going to select the Networking tab, and that's going to let me see the MAC addresses that are associated with the specific virtual switch. Right here, I'm going to move over to the right a little bit. Number 98, that is my subnet 1. So I can come over here, I can right click and rename this. Yep, you got it, subnet 1. Now I've still got these other properties up. I'm going to go ahead and close those, and I'm going to rename the other one. What's it going to be? Yeah, that's my WAN link, so I'm going to aptly name it WAN link. Now, if I come back over here to my server manager and just refresh, they're still all getting either DHCP or APIPA addresses, but I can see that they're going to actually say what they are. They have externals there. It's still refreshing, right? Let's go back over here. Where is my network connections? Here we are. Documentation. It all begins with planning. I didn't just say, you know what, I'm going to build these and I'm just going to go. No, we document things. So let's take a look. I'm going to scroll down here. If we take a look, here's my document that I've crafted. So my final project, this is a sample. Planning, subnets and links. Well, these are my subnets. Network 1, network ID for it. Subnet 2, the network ID to it. My subnet mask, my WAN link, what am I going to use? My domain name, my router 1, what are those interfaces going to be? What are the IP is going to be assigned to each one of those interfaces? What am I going to use? Am I going to use static routing? Am I going to use dynamic routing? Let the routing protocols do the work for you. I'm going to implement rep v2 and let the dynamic routing occur. What roles are going to be installed on each server? Document, document, document. Because what happens if this is your production environment and you're not there today? And one of the other administrators needs to perform some function. They need documentation. You need to document. It all begins with planning. It all boils down to documentation. There's my router 2, and I can see a little bit of difference for routing 2. I'm going to have one DHCP server. Well, how subnet 2 be able to assign IPs through DHCP? Through DHCP relay. My subnet 1, there's my gateway address. Here's what servers are going to be in there. Final DC1, its IP address, the roles that are going to be set. DFS1, DHCP, what are my scopes going to be? How am I going to configure it? All those various different things. So with that in mind, gateway address. What gets assigned your gateway address? That's the interface on your router that your subnet connects to, right? Well, if we come back over here, subnet 1, that's my gateway for subnet 1 to get out, to get to other networks, to get to the internet. We want to assign that 192.168.1.1. Default subnet mask. I'm just using classful addressing for this, not doing anything wild. I don't need to install or specify a DNS server. It's getting that from my DHCP on my external adapter. What's my WAN link going to be? I'm going to need to set that as well, right? Well, let's take a look back over here in that documentation. Where's my WAN links? Where did I oh, there's where I documented it. Yeah, it's documented. Router 1, 10.1.1.1 with a subnet mask of 255, 255, 255, 252. That means I'm only consuming 4 IPs. Maybe I've got many WAN links. But remember, you can't use the first, can't use the last. That gives me my two IPs that I need to connect those two routers together. Let's get back over here. 10.1.1.1, 255.255.255.252. Here again, this is the gateway on how things get back and forth, so I don't define a gateway. One gateway, one machine. That's on my external adapter. Preferred DNS, don't need it. I already got that. I can go ahead and I can close my network connections. If I refresh, let's see if this thing's behaving fine. Yeah, look at that. The memory requirements came down. And there's our settings. There's our settings. I can go ahead and install my role. Add roles and features. Next, next, next. Remember, this is role-based. Where's my routing? There's my remote access. That's where I get access to routing. I click next, next, next. We're going to select routing. It will also select direct access and VPN, but we're not going to be configuring those. We're just worried about routing. Next, 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 and install. Does not require a restart. Sometimes it's not a bad idea to go ahead and restart anyhow. While that's going on, you got it. I'm heading over to the other virtual machine. Final router 2. On this one, I only have two adapters, subnet 2 and my WAN link. I need to figure out which is which. How do I do that? How do I figure out what adapter is connected to what virtual switch? That's right. I go to status. I go to details. Okay, number 9C. My Ethernet is attached to MAC address 9C. Back to my Hyper-V Manager, I'm going to select Final Router 2. 9C, that's my WAN link. See, if I just said, oh, that's probably my subnet, I would have had them backwards. I would have had all sorts of connectivity problems. So we're going to right-click on Ethernet. We're going to rename. I'm going to name it WAN link, and since I don't like using the mouse, I'm just going to hit Tab and name it Subnet 2. I can set my IP addresses, right? Right-click, go to Properties, double-click IP version 4. Use the following. This is my gateway for Subnet 2 to get to anywhere else. 192.168.2.1. It kept it simple. Look, the one dot indicated which one of my subnets I was on, right? Now you're not going to name them Subnet 1, Subnet 2, Subnet 3, but I'm just keeping it simple. But both of my gateways, whether it's on router 1 or router 2, both of my gateways end with .1. They could be .54, whatever, but keep it uniform. Both of my domain controllers are going to be 192.168.1 or .2.2. Keep it uniform. Tab sees it's classful. We click OK. I'm going to click OK once more. My WAN link. Internet Protocol version 4. Static IP address. Router 1, its WAN link was 10.1.1.1. This is going to be, yep, you guessed it, .2. Remember 255, 255, 255, 252. Click OK, click OK. We can close, we can close, we can refresh. Now, should I be able to ping router 1? They're both on the same subnet, right? They got the link. Let's take a look. Can I ping 10.1.1.1? Ooh, no, why? Why not? Come on. You know the answer to this. Why can't I ping 1.1? It's timing out. It's not telling me that it can't get connectivity. I'm going to hit Control-C. Let's just make sure our IP is configured. Yeah, it is. I hear you saying it. Firewall rules, right? We have to allow ICMP v4 inbound. By default, it's turned off. I'm going to do it over here first. Windows Firewall with Advanced Security. I could do it from PowerShell too. Inbound rules. You scroll down to File and Printer Sharing, Echo Request, ICMP version 4. Right click, Enable. I'm going to close that, jump over to my router 1. You can see my configuration's done. It's installed the role. No, I'm not going to configure direct access and VPN, so I am not going to click this Getting Started wizard. I'm simply going to close the Add wizard screen. I'm going to go to Tools, Firewall with Advanced Security, Inbound Rule, FPS-ICMP4-ERQ-IN. That would be the PowerShell commandlet, or what you would enable to create a new firewall rule, or rather enable a new firewall rule. There, it's there. I'm going to close this. Command prompt. Let's see if we can ping 10.1.1.2. Oops, need a dot there. Hey, we're in good shape. We got connectivity there. Let's jump back over here. Bring that command prompt up arrow one time, repeat the last command. The two routers can talk to each other. We're on our way. We are on our way. I'm going to leave command prompt up over here. We're going to go to Tools. Remember, that's where we find all of our tools, just like a carpenter has a tool belt. Tape measure, hammer, nails, all those different things. Tools is where we find those things. We're going to come down. We're going to go to Routing and Remote Access. First thing we need to do is we need to configure it. The role is installed, but it's not configured. So I'm going to right-click on the server name and select Configure Enable Routing and Remote Access. The little wizard description screen comes up, and we've got some out-of-the-box configurations that we can pick. But remember, this router not only needs to provide access to the internet for NAT, but it also needs to do LAN routing. I don't see where I can do secure connection between two private networks. No. I can do NAT, but that's only going to connect my one subnet. I need to do a custom configuration. Click Next, and now I can select NAT and LAN routing. We'll do Next and Finish. Now, you're probably going to see the same thing. Remote accessor is unable to enable routing and remote access for the probable reason. Ports aren't open. It's not been configured yet. We're going to click OK. Guess what it's doing? It's enabling those rules for us. The service isn't running yet either. The service needs to get started. And as you can tell, it's a little chilly in the classroom today. Ready to get some mitts out. I think I was up north somewhere. A little chilly in the classroom, even though it's Florida. So we'll start the service. Waiting on for it to start. There we are. There we are. Going to go ahead and expand that server. See what we've got here. There's our IPv4. There's our NAT. What do you mean nothing's showing up there? General. Well, there's our external. There's our subnet 1. There's our WAN link. We're going to right click on that. We're going to say New Interface. I'm going to select the external. It's already selected at the top of the list. I'm going to click OK. And it's going to say, which is this? Is this connected to your private network, or is this connected to the internet? Remember, this is external, so this is connected to the internet, and we're going to enable NAT on that interface. We're going to click OK. If I come back to NAT, there's my external, but that's all it's listed. I need to add my subnet 1 and my WAN link. I'm going to right click once more, new interface, subnet 1, click OK. Private interfaces, private network, click OK. Right click, new interface. All we got is the WAN link. We're going to click OK. It's private, connected to private. We click OK. There we are. We're configured, almost. I'm going to go ahead and I'm going to add that routing protocol while we're here. I'm going to right click, say new routing protocol. I right clicked on general on IPv4. There's my RIP version 2. Don't see it here, but if I click and up there, it appears. This thing's still running a little slow. So you know what? As soon as we're done here, I'm going to restart this. I'm going to right click RIP, say new interface, my subnet 1, click OK. Just going to accept all the settings. We're going to click OK. I'm going to do the same thing again for my WAN link as soon as this finishes. There it is. Right click, new interface, WAN link, click OK. And click OK. Alright, now my router is configured. I'm going to go ahead and tell this thing to shut down. After it shuts down, I'm going to restart it. So I'm going to right click, I'm going to shut down, plan, shut down, continue. Over here, I'm ready to configure this. So I'm going to do manage, add roles and features. Next 3 times. Next, it's role-based, next. It's the only server it's listed here. Next, remote access, add our administrative features. When we select routing, there they are. Next, 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 and install. Let's go back over here. I'm going to refire that router 1. I love how fast these differencing disks make the job. Also working off solid state drives. That's a big difference. Remember, virtualization relies on your memory, your CPU, but real important, disk speed. Alright, let's make sure we've got access to the internet. I'm going to ping 8.8.8.8. Okay, I got that. Now from here, I should have DNS, so I'm going to do a ping-A to resolve the A record, the DNS A record. Yes, it did. Resolves DNS.Google. So we've got connectivity here. Let's just still make sure that I can ping 10.1.1.2. I can. Can't resolve a name because there's no DNS there, right? We'll come back over here. We're almost done here. This router's done. This router's configured. Now we got some services that show some errors. Don't worry too much about that. Is routing and remote access stopped? Really? Let's take a look. Remember, delayed start means it's not critical for the operation of the server. That's why it says delayed start. If I right click on, say, start the service, it's going to start. DTC, I can start that. They will start, they've just delayed. Right? If I come back over to here, we can see if I refresh this, it's in the green. We're good to go. NAT, if we look under RIP, there we are. Under general, we can see some incoming, outgoing bytes. We got some traffic. Let's take a look over here. We're done. I'm going to click close and tools, routing and remote access. I'm going to right click, configure. Next. This needs to do LAN routing. So I'm going to do custom LAN routing. Next. Finish. Same warning. Don't worry about it. setting things up for us. It's doing the job. We're ready to start the service. We'll let that get started. We're pushing 36 minutes or so here on the video. So as soon as this is done and we're up and running, I'm going to end this video, and then we'll proceed to part 2, which is going to be configuring our domain controller, starting to build our network out. If we look here, static routes, no, I want to do RIP, new routing protocol, RIP version 2. Click OK. There's my RIP. You know what? This is also going to need a DHCP relay. I'm not quite ready to configure that, but I'm going to go ahead and add it. It's there for me to configure as soon as I'm ready. Under RIP, I'm going to select it. There's no interfaces for it to listen to, so I'm going to say New Interface, Subnet 2, click OK, right-click, New Interface, WAN link, click OK. Let's take a look here. If I right-click on static routes, let's show the IP routing table. It knows about the 10.0. It knows about that network. Look, 192.168.1.0. It knows about the other network. It knows how to get to it. If I want to reach a destination on the 192.168.1.0 network, I need to go to 10.1.1.1. We're in good shape. Let's see if I can get to the internet. I'm going to run another command prompt. First thing I'm going to do is I'm going to do a ping 192.168. Oops, 168.1.1. That's the gateway over there, remember? I can ping it. Yes. How about, can I ping 8.8.8.8? Ooh, got a general failure. I'm going to have to troubleshoot this. It's not getting to it. I'm going to have to do some troubleshooting. So that's going to be part of our next video. I'm going to wrap this up now. We're going to troubleshoot that, and then we're going to return with that solution in our next video, all right? But right now, Subnet 1 can talk to Subnet 2, Subnet 2 can talk to Subnet 1, and Subnet, the router, can get access to the internet. Now, once we start building out infrastructure, maybe then we can troubleshoot some of these other problems. So, that's it for this video. I hope you enjoyed it. It's a great start to how we build our final project. There's going to be more in the following videos that are to come. Thank you.